In this video, we will discuss that how the metric is calculated in EIGRP. So first of all, we will talk about legacy EIGRP. So this is the formula what you can see here for calculating the matrix. And as you can see, there are different K values, K1, K2, K3 and K4. Now K1 is multiplied by 10 to the power of 7 upon minimum bandwidth. Now, what is the meaning of minimum bandwidth here? For example, you have 5 routers connected and the minimum bandwidth is 10 Mbps. Maybe some routers are connected via 100 Mbps, some routers are connected via 1 Gbps link, and some router in between is connected by 10 Mbps. Then that 10 Mbps will be taken. So it depends on bandwidth and it depends on load. How load works, we will also discuss. And K3 into total delay upon 10, and how delay will be calculated we will also tell. And K5 upon K4 plus reliability. Now reliability means which link you are using. You are using serial link, you are using Ethernet link. So this is the formula basically, which depends on bandwidth, delay and reliability and different K values basically. So bandwidth is the lowest amount of bandwidth available on the path in kbps. Delay is the total delay for the path. It means if you're hopping from one route to another route, then another router, then another router. So all the total delay will be calculated. K1 and K3 has a default value of 1. K4, K5, K2, K4 and K5. Which one I am saying? K2, K4 and K5 has a default value of 0. So these are some default value and this also varies basically. Now we are simplifying the formula more here. Okay, for example, RFC 7868 states that if K5 is equal to 0, then reliability quotient is defined to be 1. Now K5 is 0, then the value of this whole value will be 1. Now the formula is simplified. So as you can see, this very simple formula, and that is matrix is equal to 256 10 to the power of 7 upon minimum bandwidth and total delay upon 10. Okay, now reliability option is not here basically. So this formula is much more simplified right now. So this is very simplified formula and you can use within the Excel. Let us discuss more. Now EIGRP path attribute. Okay, so EIGRP path attribute for a prefix are appended as necessary. Hop count is always increased, delay is always increased, bandwidth is lower if the link speed is lower than the update packet. Now what is the meaning of that? For example, here the link speed is 100 and delay is 100 microsecond. Now what will happen basically, what will be the attributes? So as you can see the attributes here, the hop count is 0, minimum bandwidth is 100 mbps, total delay is 100 ms. Okay, and reported distance, which is calculated with the help of previous formula K1 and K2 formula, that will be 28160. Now we are coming to this link. Now when we are coming to this link, as you can see, the bandwidth is decreasing. Then in new packet, instead of 100 mbps, it will be 10 mbps. And delay is 1000 here. Now 1000 and 100 will be added and you will get how much? 1100. Then again RD is calculated and this is the RD. Then it moves forwards. Again here the link is 100 mbps, delay is microsecond. Now as you can see, minimum bandwidth limit 10 because that is a bottleneck basically for you, and hop count is 2 basically, and minimum bandwidth is 10 and delay is added basically. As you can see, 100, 1000, 100 delay is added, and finally we will get a feasible distance. So from here to here we will get the feasible distance. Now how we will get the feasible distance? As you can see, 28160 and 284160 has been added. How? If you use calc and let us do 28160 plus 284160, 284,160 is equal to, some value has been came here, as you can see. So we have added two value, 28160 and another value is 284,160. So feasible distance has become, should be this, but uh, you will say okay, now here feasible distance is different. So this is not done by addition. Let me tell you, you can't do this, you can't add this and this. You have to apply the formula. And which formula you need to apply? You have these values, hope count, this, and now apply the formula, then you will get the feasible distance. So initially people think that we have added this and this. No, we have not added this and this. We have done a simple calculation with the help of formula. Now if we move further, here a simple topology we have seen here, and if you really want to see the topology, you have to run the command show IP EIGRP topology. Now if I want to go from where R1 to R4, so here 10 millisecond delay, here 10 millisecond delay, here 10 millisecond delay. So total delay, if you see, is 30 millisecond. Okay, and here the delay is 100 millisecond. So if you are unsure of EIGRP metric, you can query the parameter formula from EIGRP topology by using the command show EIGRP topology network prefix length. Then you will be able to see that from where the traffic will move. So I have run this formula. Which formula? So not formula, command basically, show IP BGP topology. When I run this, then see what we have got here. So it is showing from 10.13.1.3. So if we are starting from here and we want to reach where? We want to reach basically here, where here to R4. So what is actually happening, that has been shown here. So from 10.13.1.3, send flag is 0 cross 0, okay, whatever. Now composite matrix has been came, how much? 3328 and 3072, and this route is internal route. Bandwidth is this, total delay is this, reliability is this, load is this, and MTU is this, and hope count is this. And which is the originating router? 192.168.4.4, that is basically the router ID. Now if you do a further check, now this is for gigabit 0 by 0, okay, uh, for this router 1, gigabit 0 by 0. Now another, if we see 10.12 gigabit 1 by 0, this interface they are talking about. So if you see here, now here the composite metric is bit different, 58883328. Okay, so composite metric has been changed because as you can see this delay has been changed. Okay, and here the delay was basically different. So in this way it is calculated that if you want to reach the destination, then how much hope will be there. From here we will be 1 and 2 hope, like this. Okay, and from here if we want to reach, then how much hope will be there? It will come here, and it will not like to go here basically because 100 millisecond. Then there will be, you can say, 3 hope you need to jump to reach the destination. So this is the hope count which has been shown. Now how EIGRP interface delay matrix is calculated? For example, if you have 10 gigabit connection, then delay will be 10 microsecond. Now if you have gigabit, then 10 microsecond. Now here is the problem. Okay, but you can see the matrix is changing, okay, with the help of formula. So for different connection, there will be different delay, and there will be different metric as well. Now let us move down. Now EIGRP path modification. EIGRP select route, internal routes over external route first. So it will give the preference to internal route. Then it select the path with the lowest path metric. So whatever be the lowest path metric, it will select. EIGRP path can be tuned by modifying an interface bandwidth, but can impact other routing protocols like quality of service. So if you change the bandwidth by command, then you can change the path of the packet basically, but it is not recommended. Why? It will impact your QoS setting. Modifying interface delay is a better solution. You can change the delay so that you can define that from where the traffic will move, and it can tune EIGRP traffic without impacting other systems. The interface delay can be modified with the command delay and tens of microsecond. For example, I have gone to an interface gig, and I have given a delay. Now if I will do show IP interface and including line ly, delay basically we want to see here. So as you can see, delay is 270. So we have given delay 27. Now here it has become 70 because it will multiply by 10. If we go to another sheet, then you can see the original EIGRP path metric formula measure delay in 10 microsecond units. Okay, it will basically, you can say, delay it will measure in 10 microsecond units. Measure bandwidth in kilobytes per second, it will check. This does not scale with the higher speed interfaces. As you can see, for 10 gig and for 1 gig and for 10 gig, the delay is same. That is a problem. Okay, so that's why the old EIGRP, non-named I'm talking about, is not good. So it will cause the problem for us. Now what problem it will cause? Let me see. For example, you have gigabyte Ethernet. Now this is your bandwidth, this is your delay, and if you do a composite metric, you will get 2816. Which formula I am using? Okay, I have shown you the formula. I am going up, going up, going up, going up, going up. So this simple formula which I have shown you, this I am basically using 256 10 to the power of 7 upon minimum bandwidth plus total delay upon 10. So this formula I am using. So when I am using this formula, then this composite metric we are getting for gigabit. This is for 10 gigabit. This is for 11 gigabit. So if you have two options, 10 gigabit and 11 gigabit, definitely it will go to 11 gigabit. Now here is the problem. For 20 gigabit, you will get the composite metric same. So you have 10 gig connection and you have 20 gig connection, the composite metric is same. So it will give weightage to both path, but weightage should be given which should be given to which path? 20 gigabit Ethernet. That's why they have introduced a new parameter K6 into the formula. Okay, now this is for your named EIGRP. As you can see, here they are multiplying by 65535. Now it will provide support for interface up to 655 terabyte per second. So it's very high. So we have covered the future. Latency measures in picosecond instead of microsecond. So this difference they have done, and this is the formula what you can see here. Okay, that has been used. We need not to rectify this formula, we need to understand the parameter only. So if you are seeing K6, it means you are using named one. If you are not seeing K6, then you are not using named one. Now, the interface delay can vary depend on the following logic. If the interface delay has been specifically set, the value is converted into picosecond. Earlier, it was converting into microsecond. Here, it is converting into picosecond. If you have set the delay, if interface bandwidth has been specifically set, the interface delay is configured using classic default delay convert to picosecond. Okay, so it will be converted into picosecond. The configured bandwidth is not considered when determining the interface delay. If delay has been configured, this step is ignored. So if you have configured delay, then bandwidth step will be ignored. If the interface support 1 gigabit or less and does not contain bandwidth or delay configuration, the delay is the classic default delay converted into picosecond. So if you are not giving anything, then it will convert into picosecond. If the interface supports speeds more than 1 gigabit, does not contain bandwidth or delay configuration, okay, now here it supports 1 gigabit or less, here 1 gigabit more, basically more than 1 gigabit, then the interface delay is calculated by 10 to the power of 13 upon interface bandwidth. Here we are converting into picosecond, here we are converting into 10 to the power of 13. So the differentiation can be calculated. How? EIGRP wide metric can be viewed easily by looking the output of show IP protocols. As you can see here, we can see K5 value, then it means it is your legacy EIGRP. Here you can see K6 value, it means it is your new named EIGRP. EIGRP metrics were designed backward compatibility mind and EIGRP wide metric set. So if you have backward compatibility, then K1 and K3 value it will set to 1, K2, K4, K5 and K6 will be set to 0. This allows backward compatibility because K value matrix match with the classic metric. As long as K1 to K5 are same, K6 is not set. The two metric styles allow adjacency between the router, but it is not recommended. In one router you are using named, in another router you are using classic. So if you create this kind of scenario, then definitely it will cause the performance issue. So either use named or use legacy. What I suggest, use named only, so that you will get the latest set of configurations. EIGRP wide metric backward compatibility. EIGRP is able to detect when peering with a router is using classic metric, unscale the metric into formula. What it will do, it will calculate the unscale bandwidth, EIGRP bandwidth, the normal one, then EIGRP classic scale upon scale bandwidth. This conversion result in the loss of clarity of route passed through a mixture of classic metric and wide metric devices. As a result of path learned via metric peer always look better than the path learned via classic path. This could lead to suboptimal routing. That's why always used named one and just forget about the legacy one. Here is one more example you can see here. It's a very good example. If you talk about successor route, now add 256, 256 and this, okay, then add 2560 and 2816. Obviously this sum will be lower, this sum will be higher, so this will be the successor route and this will be the feasible successor. It means when this goes down, it will go via this path. So the route with the lowest metric is called successor route. The value calculated by using the formula to reach the prefix, that is called your feasible distance. So what is the feasible distance? This plus this plus this, that is called your feasible distance. Reported distance, now what is the meaning of reported distance? For example, for this router, what is the reported distance? 256. 256, this is the reported distance. And also let me show you one more thing here. First of all, so I have run the command show IP EIGRP topology. So they are saying that if you want to reach 10.34.1.0, you want to reach where, sorry, here they have basically calculated, and they want to go from here to here. Okay, then what is happening basically, then it is saying you have two paths basically. First path is 10.13.1.13, second path is 10.14.1.4. so this path is given. So I am more interested in here because I want to reach where, I want to reach 10.4.4.0. I want to reach here basically. So let us see, it has two paths. Okay, first path, if you can see this 3328. Now what is this 3328? This 3328 is what is called your feasible distance. At this, this and this, you will get the feasible distance. And what is the reported distance when you reach here? So reported distance is 3072. Okay, this is the reported distance. Now how this reported distance and this feasible distance is calculated, we can see very easily. So let us open the calculator and add 256 plus 256 plus 2816 is equal to 3328. So this 3328 is my, as you can see, my feasible distance. What is this? This is my feasible distance. And if we talk about 3072, now what is 3072? 3072 will be my reported distance. So what is the meaning of reported distance? When I will reach here, then what will happen? Again open the calc and just add 2816 plus 256 is equal to 3072. As you can see here, 3072. So this is my, this one is my feasible distance, the whole path, and this is my reported distance. And who is reporting? Router number 4 is reporting. It is saying I have this and this. So in this way the metric is calculated, and we have two path here. Okay, now one more thing is there. So they have given you can go via here. So this is my primary route, or you can go via here. How we got this 5376? How we got this? Okay, so if we again open calculator and we add 2560 and plus 2816 is equal to 5376. So this path, this is my successor route, and this is my feasible successor. Okay, and also we can see here, so this is, if you say this is my feasible distance and reported distance. Here feasible distance is correct only. Where is my feasible distance? This one. And reported distance is 512. What should be the reported distance? This is wrong. The reported distance should be basically, if we talk about for this router, what's the reported distance? It is giving this value 256. Okay, so don't get confused, it is giving the lower one basically. So this is how this will be your successor route, this will be your feasible successor route. first path and second path. So this is how the things are calculated. So this is feasible distance, we have two paths, this is first path what is recommended, this is second path. And also if I run the command show IP EIGRP topology all links, so you will be able to see what you will be able to see feasible distance and reported distance. So feasible distance, reported distance, feasible distance, reported distance, feasible distance, reported distance. So this will be my first path, this will be my second path, this will be my third path. So now you can understand what is feasible distance, what is reported distance, what is successor route, and what is feasible successor route. Okay, so this is my second part, that is called my feasible successor. So feasible distance, reported distance. So this we have learned basically. Equal cost multipathing. Now as you can see here we have two paths. Here metric is 3328, 3328. Obviously the traffic will go from both paths. EIGRP allows installation of multiple paths into a routing table. It requires that the paths are the same type and have same feasibility distance. So feasibility distance is same, this one. So that's why it is what it can do. It can do equal cost multipathing. It allows for load balancing up to maximum number of paths. The default value is 4, but that can be changed with the command maximum path max path. Okay, so you can change the path that up to how many path. Okay, it allows load balancing up to maximum number of path. So the default value is 4, but you can increase it that up to how many, you can say for load balancing that up to how many path we can use ECMP. By default is 4, but you can change with the help of maximum path. So if I run this command show IP route EIGRP and B gateway, as you can see here, what is this 90? If you can see here, and these are two routes basically, and this is 103330. Okay, so what is this? This is your feasible distance, this is your reported distance, this is your feasible distance, this is your reported distance. That's why it can do ECMP for reaching this IP, because feasible distance and reported distance both are same. Now unequal cost multipath. So it can also do unequal cost multipath. It means cost is different, still you can use multipath. So allow installation of both successor routes and feasible successor into EIGRP rig. Okay, you can add feasible uh, successor successor route and feasible successor route. You can put it into routing information database basically. Require the manipulation of EIGRP variance number, which is calculated by dividing feasible successor FD and successor FD, and whatever value will come, do a mod of it. Now what is the meaning of mod? If it is coming 1.7, consider it to be 2. Okay, so that is the thing. Variance number is the whole number and remainders always round up. Okay, EIGRP variance rule is the feasible distance for a route manipulated by EIGRP variance multiplier and feasible successor FD. Okay, with a metric below the EIGRP variance value is installed into RIB. I will show how it will be done. EIGRP install multiple routes where feasible distance for the route is less than EIGRP multiplier value up to maximum number of ECMP routes as discussed earlier. Now, by reading this, you cannot understand. I will show you. For example, now what I have done, here the delay is 10 microsecond. Here the delay is 1 microsecond. So definitely this metric is good. The data will go from here, but you don't want to do this. You want data should go from both paths. So if you do show IP route EIGRP, then what it is showing that if you want to reach 10330, then what values you have basically. Okay, so there are two things what we have learned here: feasible distance and reported distance. And here's the formula: feasible successor FD and successor FD. So if we carefully see from here basically, okay, so here 903328, 903072, 903072. Now obviously if you see, it will try to you go via this path, but you also want it should go via this path as well. Now how it can be achieved? Take the feasible successor FD upon successor FD. How we can get that? Show IP EIGRP topology. So this is feasible successor, this is successor, and for this path this is feasible successor and this is successor. If you divide 5632 by 3072 and you will make it a whole number, then you will get 2. So variance is 2. So the variance multiplier is configured with the command variance multiplier. The command is placed under EIGRP process with the classic configuration and under the topology base in the named mode configuration. For example, configure terminal and router EIGRP 100, and what command we are using? Variance 2. So as soon as we will put this variance 2 command, something will change. Now what thing will change basically? Now if you are doing variance 2 and you are running this command, show IP route EIGRP. Now if you see, I want to go where? 10330. So here we can see 903328, 905632. So ideally traffic should go from here. Okay, but let us go further. If I run this command, show IP route 10330, and this excluding MTU, hope, update, and EIGRP. So as you can see from here, we have two interface. The first interface is 0 by 0, another interface is 1 by 1, and see what is the traffic count share. Traffic is going from both paths. For first link, the traffic share is how much? 120, 3228. For here 120, it is taking more traffic with the variance. And from another path, it is the traffic share is 71. It means now we have achieved the load balancing in EIGRP. So these are some metric thing which you can use and you can manipulate the path. So with the help of variance, we can manipulate the path. With the help of, you can say, we can change the latency, we can change the path. So these are something, with the help of this we can control and we can change the path. So this is all about EIGRP path selection method and matrix. Thank you.